Hi, my name is Jeff Coronado from JCSE, and this is a session in Bridging the Gap. We are going to be covering WPF7B, Typical Mechanical Equipment Platform -1. So this is the first in this sequence. What are corner weights? Okay, sure. Valid question. Um, Scroll down here a little bit. Okay, so I think intuitively we would all recognize that many rooftops, certainly in commercial structures, will have roof-mounted mechanical equipment, right? Um, and it's intuitive that that mechanical equipment is going to have a certain weight associated with it. Therefore, our structure, the roof framing, has to be able to resist the weights induced by that mechanical equipment. So I think at first blush, if you think about it, you might think, well, if I have a mechanical equipment, as long as I know the weight of the mechanical equipment, I can divide it by the surface area of that unit and get a uniform pressure distribution resulting from that unit. However, that would lead to a potentially unsafe design if you were to do that, because the reality is the unit is not symmetrical, so you do not have a uniform pressure that is induced by the unit. In fact, let me see if it is most likely there will be symmetry about the longitudinal axis. If this is a schematic representation of a rooftop mechanical equipment, so this is a plan view, a bird's eye view, right? What in the industry we call a plan view. In school, you might have called it a top view. In the industry, we call it a plan view. So this is the plan view of the mechanical equipment, right? In black, you have beams along the edges of the unit, and then you have girders that support the beams. So we're showing two beams and we're showing two girders. If you look at the mechanical equipment, if you look at the axis, the centroid axis along the longitudinal direction of the unit, there will be symmetry in all likelihood. I shouldn't guarantee it. In all likelihood, there will be symmetry about that line. However, if you take a look at the axis of symmetry along the transverse direction of the unit, in this direction, there won't be symmetry about this line. So in this direction and in this direction, there will not be symmetry. Now, how do you know that? Well, if you are in the process of designing this, if it's within your control, then you can put in a request of the mechanical engineering, who is the one that's dictating the size of these air handlers, of these mechanical equipment, and request cut sheets from them. Okay, if they give you cut sheets, then those cut sheets will provide the corner weights for the equipment. If you are not getting cut sheets for whatever reason, perhaps you're evaluating a structure that's already built and you have the mechanical equipment, you know the mechanical equipment, but you're not getting cut sheets for it. You may have to make some assumptions. Um, usually you will be safe to assume that anywhere between 60, 66, let's say two-thirds, about 66, 67% of the weight of the mechanical equipment, that would be the lower bound of your assumption. So your assumption should be, let me see if I write this for you. if you have to assume that 66% up to 75% of the weight is on one edge. So let me see if I can explain this to you. Okay, so we've already established it is not a good idea to assume that the weight is applied uniformly over the surface area of the mechanical equipment. In part, that's also due because there may be ducts that have to go down through the roof framing that supply air down into the living space or into the occupied space, I should say, to the occupied space. And there's also return ducts that may be coming up from the occupied space into the unit. So you don't exactly know what the penetrations are that they're going to be there. So it's not like there is a uniform support underneath the mechanical equipment. So what we tend to do is the way we look at it is we're going to assume that the weight that's within the mechanical equipment simply distributes out to the walls of the mechanical equipment. Okay. So the weight that's in here distributes out to the walls of the mechanical equipment. So we assume that the edges of the mechanical equipment is what's loaded, not internally, but only the edges. And then the walls of the mechanical equipment simply transfer the weight to the corners. Okay? We transfer the weight to the corners. So that if all you did was to provide, let's say, four little supports, four legs almost, if you will, four legs, one leg under each corner of the mechanical equipment, we would be okay. We would be okay. The unit, the housing of the mechanical equipment, would be able to support itself. Uh, would be able to support itself if provided each corner is supported. So that's how we base our design. Now, this is true unless that unit is a very large unit. But again, you would, if that is the case, you would have more direction from the mechanical engineer if that were to be the case. Okay, so let me clear the screen here. So again, kind of remember this rule of thumb. Um, if you do not know what the corner weights are, then you assume 66 to 75%. 66% is like a lower bound, 75% is probably a better idea. Assume 75% of the unit is on one edge. Um, let me see. Let me see if I can erase this. Okay, so I'm erasing this so that we can keep that rule of thumb. So what we're saying is 75% of the weight is going to be on one edge and 25% of the weight of the mechanical equipment is going to be on the other edge. Right? Again, notice how it's not a 50-50 proposition, right? That much we almost can guarantee. It is very unusual that we would see a mechanical equipment that has a uniform distribution where we actually get corner weights from the mechanical engineer and we see that the four corner weights are almost the same. That's not realistic. Again, we're going to find that they're going to be varying, that they will vary from unit to unit, but they're going to be pretty close to somewhere between 66% and 75%. So if you don't have that information provided to you by the mechanical engineer, and you need to make an assumption, probably 75% will lead to a conservative design. Closer to 66% will probably be more accurate, but again, not conservative. But anything less than 66%, yeah, you're running the risk that your design is not going to be conservative. Okay, let me now clear this, and because I think some of this is what we wanted to cover and we've now been covering. So let me take a look here. Okay, so we see our layout, right? See if I can enlarge this a little bit. Okay. So item one, a corner weight represents the tributary weight load induced by the mechanical equipment due to the weight of the respective quadrant of the unit. Okay. So in essence, I think we've kind of covered that. Let me clear this and go back to our sketch. So what that means is if the load of the unit was symmetrical, then these loads that represent the weight of the unit, P1, P1, P2, P2, right? If we were to get the four corner weights and we add them up, we will get the totality of the weight of the air handler, of the mechanical equipment. However, since it's not symmetrical, then they won't be equal. In all likelihood, what you're going to see is that two of them are equal. So that's why we're representing both of these as P1, because they will be equal if you look at them about, there will be an axis of symmetry along the longitudinal axis, which is what we previously said. That's why P1 and P1 are the same here. Likewise with P2 and P2. The totality of the four corner weights will get you the total weight of the mechanical equipment. Now, keep in mind when we do this, there is also a platform, a curb, which has some weight that you will also need to account for. But we're not getting into that here, since right here all we're covering is the corner weights. Probably, I think we'll cover that in the second session for this particular detail. All right, moving on to the second item here. In the figure, and it says figure below because again, this is coming from our in-house manual. So for those of you that are following in-house, yes, the figure will be below, but that figure here where we say the figure below is what we're showing in this image up here, okay? So in the figure below, P1 are the heavy corner weights and P2 are the light corner weights, okay? So again, if I were to just throw some numbers, let's say this mechanical piece of equipment weighs 1,000 pounds. Okay, so if this weighs 1,000 pounds, what would be reasonable? Maybe this P1 might be 350 pounds. So P1 might be 350, and then this would be what, 150 a piece? Sure. This would be 350, this would be 150, this would be 150, and this would be 350. So the total weight of the unit is 1,000 pounds. But again, they're not equally distributed. Okay, so there will be two corners that will have the same weight, but it will be higher than the other two corner weights. And the other two corner weights will also likely be equal, but they will be less. Their sum will be less than the two corner weights that were heavy. Okay, let me see if. Okay, so that gets us item 2. Item 3, therefore, beam 1. Okay, so beam 1 supports the heavy corner weights. All right, let me clear the screen here. So beam 1, which is this one, we can see here, beam 1, that's this beam here. This supports the two heavy corner weights. whereas beam two is supporting the two light corner weights. All right. All right, item 4 here. The static analysis of beam 1 simply includes the concentrated force P1 acting at Y1 and Y2. Okay, so if we go up to our diagram, let me see if I can zoom in a little bit more on this. So what we have is a simply supported beam, right? It will be a simply supported beam with a concentrated load resulting from P1 and a concentrated load on, I'm sorry, concentrated loads, but they're the same magnitude, right? Now, keep in mind again, we are only looking at the effects of the equipment, of the mechanical equipment, right? There can be other loads, and in fact, there will be other loads, both uniform loads, maybe partial uniform loads, maybe concentrated loads if there's any beams framing into beam one. So there is other loading. Right now, all we're focused on is the loading on beam one that is resulting from the mechanical equipment. Okay, so from the mechanical equipment, you will have two concentrated loads, P in magnitude P1, and they are located at, not use that arrow. They are located at a distance Y1 from the support and Y2 from the support. Okay, two concentrated loads, magnitudes of P1 at Y1 and Y2 from the support, only resulting from the mechanical equipment, right? This doesn't include the weight of the platform, other roof area tributary to beam one, other beams that are tributary to beam one. This is only looking at the mechanical equipment. All right. If we go on to item 5, keep track of any additional loading tributary to the beam beyond the corner weights. Absolutely. Item 6. For design purposes, keep in mind that beam 2, the one that supports the light corner weights, is likely only theoretically correct. Beam 2 will be the same as beam 1, since in practice we do not know which way the heavy side of the air handler will be oriented. Okay, good. Good point. Let's go back up here. Okay, so theoretically, sure, we can say, well, P1, what did we say in when I was mentioning some numbers? P1 was like 350, right? P1 is 350, so this corner weight is 350 pounds, this corner weight is 350 pounds, this corner weight is 150 pounds, and this one is 150 pounds. But what if when the builder gets out there and they're putting this unit on there, yes, they can put it on like this, or they can rotate it 180 degrees. Either way, the unit ends up kind of longitudinal axis going horizontally. Sure, we can show that the longitudinal axis of the unit is oriented horizontally, but we can't specify whether we can't sit there and tell them, okay, we want the heavy side over here, or we want the heavy side over here. Can't do that. Okay, so we have to kind of assume that the heavy side may be on the left side, or we have to figure that the heavy side may be on the right side. So what's that do for us? Well, that means that this beam that we designed, beam 1, designed for P1, right? Two P1s, two concentrated loads of P1. The reality is we have to put beam one, whatever size we get for beam one, we have to put it on the other side as well. We have to kind of like envelope that solution because the reality is that the concentrated loads can be along the left edge or along the right edge. So either way, the size of the beam is going to be beam one in both cases. So we can't design beam one to be a heavy beam. Let's just say hypothetically using lumber as an example, a 4x12 beam. We can't say that we're going to have a 4x12 beam along beam one for beam one and a 4x8 beam, 4x8, a smaller beam as beam two, because we don't know if the heavy loads will be along the right side or the left side. So to protect ourselves, to be safe, to provide a structure that is adequate, regardless of where the heavy side ends up, we have to put a 4x12 along the left side and a 4x12 along the right side. Okay, I think that was item 6. Item 7, beam 1 will in turn generate reactions R1 and R2 on the respective girders. Okay, so yes, here's beam 1. So beam 1, and that creates a reaction here, and we're calling that R1, and a reaction up here, which we're calling R2, right? No reason to believe they're going to be the same, and in fact, pretty unlikely that they would be the same. It means everything would have to be symmetrical, right? P1, the P1s would be symmetrically placed on beam one, and any other tributary loading on beam one would have to be symmetrical. So, in all likelihood, R1 and R2 are not going to be the same. But then, okay, I think that was the point there, right? Let me see if I can clear this and get back to our notes. So beam one will in turn generate reactions R1 and R2, okay? In practice, in all likelihood, you will not design beam two. Right, we've covered that, right? You will design beam one and place that beam along both edges of the mechanical equipment, okay? Covered that. All right, so now we're looking at the girders, although we're calling them beams here, that's okay. They're either girders, you can call them a beam, you can call them a girder, it doesn't really matter. Point is, beam one here is supported by beam 3 at the top and beam 4 at the bottom. Likewise, beam 2 gets supported by beam 4 at the bottom, beam 3 at the top. Excuse this little area right here. This is kind of an interruption that occurs due to the paging, but in reality, this is just the same unit that we've been dealing with. Okay, here's the mechanical equipment, the beam that supports one edge, the beam that supports the other edge, right? And keep in mind how these edges are supported doesn't really matter because all you really care about is that there be a beam, that there be some kind of support at each corner. So whether the beams that support that corner are running in the horizontal direction or in the vertical direction doesn't really matter, right? As long as there is a beam, something of supporting the corner of the mechanical equipment, that's what you care about. Let me clear this. Oops, am I there? No. Okay, beam 3 and beam 4, and again, it says in the figure below because that's how it's oriented in the in-house manual, but here we're looking at above the notes, are the carrying girders for beams 1 and 2. Beam 3 supports R2 and R3, okay? Beam 3 supports R2 and R3, but excuse me, but you must envelope the design since you do not know the orientation of the air handler. Okay, so meaning you have to do beam 3, you almost have to analyze it twice. You have to analyze it if the heavy corner weights, if P1 uh, were here and here, right? And then P2 here and here. All right. Then you analyze beam 1 and you analyze beam 2, and then you get reactions, which we're calling R2 and R3, located at a distance of X1 and X2 from the left support. This is for the design of beam 3. But keep in mind that the unit can be inverted, right? So that this becomes, instead of this being P1, this might be P2. And this might be P2. And this might be P1. And this might be P1. So if that's the case, again, depending on the location, depending on X1 and X2, that might give you higher shears or higher bending. So you have to make sure that beam 3 can handle both orientations of the mechanical equipment. So you almost have to evaluate it 2 different times and envelope your solution so that so that for whatever the maximum moment is in that situation, whatever the maximum shears are, wherever those maximum shears may occur in both scenarios, beam 3 is able to resist that loading. Okay, so that's kind of the important thing there that we're trying to stress. Beam 4 supports R1 and R4, and again, you must envelope the design for the orientation of the mechanical equipment. Okay. All right, excellent. So with that, that concludes WPF 7B-1. Okay, guys? Make sure that I covered everything. That was 8. Yeah, that covers everything. Excellent, guys.